Today we're looking at note 7-5, logarithmic functions. So we are going to be looking at two different logarithmic functions. We're going to be looking at y equals log base 2 of x, that's how you read that. And we're going to look at y equals log base 10 of x. So if there's no base written, kind of like that 2, it's a subscript. If there's no base written, 10 is implied. So if no base is written, 10 is implied. And this is called our common log because it's a very common base when dealing with logs. Okay, so like I said, we're going to look at these two different log functions today. And in the future, on your assignment, you're going to be working with various different bases. So I have chosen some inputs or x values to plug in on purpose to get outputs to be able to look at these two graphs. So we don't know much about log. We don't really know what it means to take the log of something. I promise we will soon enough. But since we don't at this point, we're going to have to utilize the calculator a bit. So in the calculator, there is this, a series of buttons. It's alpha, window, 5 if you have the new operating system, alpha, window, and then 5, because as you can see that says log base, allows you to put in a log of various bases, so in our case base 2, and then we can plug in the input of -2. So log base 2 of -2, what's it going to tell me? It tells me error, non-real answer. So when I plug in -2, our output is an error. Okay, so I'll quit. My calculator allows me to go back up and copy and paste, so that's what I'm going to do. I'm going to plug in -1 for the next input that I have here. And again, it tells me error. Uh-oh. And then when I go to plug in 0, let's see what it tells me. It still tells me error. Okay. So then let's get to this 1/8. So I'm going to utilize the alpha y equals key to type in 1/8. I'm going to delete that 0. You know the DEL is the delete button. Okay, and it gives me -3. Okay, and of course I did it the same way. I just didn't want to keep writing that forever. So then I'm going to plug in 1/4. I get -2. I'm going to plug in 1/2. I get -1. I'm going to plug in, what is this here? 1. So I'm going to delete the fraction. Plug in 1. I get 0. Oops. Plug in 2. I get 1. Plug in 4. I get 2. And last but not least, plug in 8. And I get 3. Okay, so when I go to plot this, 1/8. Over here at -2, -1, and 0, I had an error, so nothing's going on over there. Okay, if I plug in 1/8, a pretty small fraction, I got -3. So really close to the y-axis here. And then 1/4 was -2. 1/2 was -1. 1, 0. 2, 1. I bet you these numbers might be looking a little familiar to you, hopefully. And then 1, 2, 3, 4, 2. And 8, 3. This graph kind of looks similar to something we've done before. You can see what's going to happen here. As you might imagine, it's going to continue to go to the right and rise. And what's this going to do? Similar to another graph that we've had. Well, notice we weren't able to plug in -2, -1, and 0, so nothing over here. But I bet you, just a little guess here, if we kept getting smaller and smaller with our fractions, but not ever getting to 0, that we would keep getting lower and lower. So what is that called when we have that situation? Remember, we dealt with this before. So there must be an asymptote kind of binding us in, right? We have a bound, so to say. Okay, so we can't go over here to the negative x values or even on 0 because we have an asymptote here at x equals 0. The graph is going to continue to hug the asymptote and get as close as it possibly can and keep going down. That's why I put the arrow here that you can see. However, we will never cross or touch this asymptote. So what would be the domain of this graph? Okay, the domain of this graph in set notation will be x such that x is greater than 0, not greater than or equal to, just greater, or in other words, 0, comma, infinity. Make sure you're using parentheses, not bracket. Okay, my range, since the graph is going to go all the way down, and it's going to climb up. Yes, it's going to the right, but it is going to climb up forever. My range is going to be y such that y is an element of all reals, or that negative infinity to positive infinity. My asymptote now is at x equals 0. And I don't have a y-intercept because I have the asymptote on the y-axis, but I do have an x-intercept at 1, 0. And then let's talk about max and min on the interval 1 to 5. So 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, so we do have kind of an issue here. Our max is definitely going to occur at f of 5. But I don't have that value here. It's not a whole point here. It's not a integer value for a point. So I would have to plug in 5 for my input and find out what f of 5 is. So f of 5 is, and let's go ahead and round to the hundredths place, 2.32. 2.32. My min, however, is clearly on the graph. My lowest point within this pink region or on the boundary is this f of 1 equals 0. That is my min. Okay, so let's look at the next log graph that we have here, the one where we have log base 10 of x, the common log. Okay, so similarly, I have these x values that we're going to plug in. Now, on your calculator, you actually have, where is it? Right here next to the number 7, you have the log base 10 button. So notice that doesn't have the space where I can put whatever base I want, so I didn't have to use the alpha window 5 for this. Common log or log base 10 does have its own button on the calculator. So log base 10 of -2. Error, fancy that, can you believe it? So log base 10 of -1. Again, error. What do you think is going to happen when I plug in 0? So log base 10 of 0. Oops, I forgot to close the parentheses. That's okay. Oh, still error. All right, so log base 10 of 1 over 1,000. -3. No, I guess I don't need to. Log base 10 of 1 over 100. -2. I wonder if these kind of look familiar, these numbers here. Alpha y equals log base 10 of 1/10. -1, log base 10 of 1, 0, log base 10 of 10, 1, log base 10 of 100, 2, and last but not least, log base 10 of 1,000, 3. Okay, so now I've got same situation where I don't have any x values in -2, -1, 0. Those were all error. 1/1000th. Oh my gosh, y'all. That is literally, I can't even, human error. I wouldn't allow me to get that close. I'm going to do my best. 1/100th, still uber tiny. Okay, 1/10th is still like, oh my gosh, it's still super close. 1/0. 10, 1, and look, I can't even go any further than that. I can't go 100, 2. So again, same situation that we've dealt with before. This is really flat compared to this graph, okay? And of course, as you might imagine, I do have an arrow here, so make sure you draw it. Okay, the arrow might go past the y-axis here, but the line, the curve should not. The arrow that you draw may, but the curve should not, because as you might imagine, what do you think we have here again? Another situation where we have an asymptote. We're never going to cross, never going to touch this line. Okay, we're just going to hug it forever. It's going to keep getting closer and closer, as you can see by these values here. 1 1,000th. It'd be 1 10,000th, you know, -4. I bet you if it follows the same pattern, right? It's going to get closer and closer and closer, but it's never going to quite touch. So what's my domain of this guy? Same as this one. My range is the same. Yes, it climbs slower. It's not as steep, but it is still going to climb nonetheless. Slowly, but surely. My asymptote is the same. My x-intercept is actually the same. Now my max and min, of course, won't be the same. So from 1, 2, 3, 4, 5. Of course, my max is going to occur at f of 5. We don't know it yet. We'll plug it in. And our min does occur at f of 1 equals 0. That's surely the case, that my lowest point in this pink region is here on the leftmost boundary. My highest point is here at log base 10 of 5, which is it's going to make me round up if I do 2 decimal places, 0.70. Okay. All right, so what we're going to do real quick is pause if you need to get your pink notes, because what we're going to do is we're going to fill in our second to last, can you believe it? Our second to last parent function. We've got the logarithmic parent function. Now on this one, we have base 10. Base 10 is implied when no base is written, so you will want to take the information off of this. Remember, we only use set notation on our pink notes, okay, just like we've been using all year. So take the information from this sheet, transfer it over, and let me go ahead and highlight real quick the points that you are going to have to memorize or plot. Okay, and here it's this one, this one, this one, this one. Okay, so on this one we've got, since this is the base 10, we've got from the white paper that you have 1/10, -1, 1 0, and 10 1 when we're dealing with base 10. So I'm about to pull this away, so pause the video if you need to get this information down. Make sure, just like you did on this one, I can clearly see the asymptote. Okay, make sure you darken it with your pencil if you need to. And like I said, I'm putting that away right now. So here we go. We're moving on. So hopefully you did notice some things. Hopefully you did. And I kept saying hint, 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 or whatever. Haven't we seen this before? Notice. Okay, let me get this out for you. You don't have to have this, but I want to have this. Okay, remember when we did exponential graphs with growth and decay? So notice the points of y equals 2 to the x and y equals log base 2 of x are what? So here's the points for log base 2. Here's the points for y equals 2 to the x. So 1/2, -1, -1, 1/2. 1 0, 0 1. 2 1, 1 2. 4 2, 2 4. So they are switched, right? Okay, I also want you to notice the domain and range of y equals 2 to the x and y equals log base 2 of x are, so let's look at our domains and ranges. So our domain and range for log base 2, our domain and range for the exponential base 2. What do you notice? They are what? They are switched. So my points are switched for exponential base 2 and log base 2. My domain and ranges are switched for log base 2 and exponential base 2. The asymptote for y equals 2 to the x. What was the asymptote for y equals 2 to the x? It was y equals 0. While the asymptote for log base 2 of x is x equals 0. If you were to plot the graphs on the same grid, look at them for a second. So this one looks like this. If I were to plot this over here, it would look like this. What would that be? The graphs would be a reflection over the line y equals x. Oops, sorry, y'all. A reflection over the line y equals x. Thus, y equals 2 to the x and y equals log base 2 are inverses. Yay, how cool. So therefore, I bet you would guess that if y equals 2 to the x and y equals log base 2 to the x are inverses, then what about y equals log base 10 of x? And y equals 10 to the x. Are those inverses? Look at that. Their points are switched. Their domains and ranges are switched. And if you were to graph them on the same graph, they would also be a reflection across the about the line y equals x. So that is pretty cool findings here at the end of this video. Have a great rest of your day.